Okay, this next section is 9.2, angles and angle measures. So again, I did originally record this, but my document camera that I was super excited about did not work so well. So I'm re-recording this for you off my phone and it was already done. So I apologize about that. But we'll get through this, it'll be okay. And soon you'll be back, hopefully, in class and we won't have to worry about it. Okay, first vocabulary. It is called standard position. Standard position is an angle on the coordinate plane that is in this position if the vertex is at the origin and one ray, and I drew a picture of way just to remind you, remember it's a point on one end and an arrow on the other, is on the positive x-axis. I'll read it again. An angle on the coordinate plane is in this position if the vertex is at the origin and one ray is on the positive x-axis. That's what standard position is, and I'll show you the picture. It's next after this. Okay, another part. This is a definition in the middle of it. The ray on the x-axis is called the initial side, that's your vocabulary word, of the angle, period. The ray on the x-axis is called the initial side of the angle. I did highlight initial side. Last one for this page. The ray that rotates about the center is called the terminal side, period. Again, the ray that rotates about the center is called the terminal side, and I highlighted terminal side. So I used two different colors for you on here so you could see it. So I highlighted initial side in green, and look, I'm just made I always make it in 4, 2 above and 2 below. I always make it about the same length and size. So the initial side always starts right here in the same spot every single time. This never moves. It always starts in the same spot. That is your starting point, okay? Like if you're on a racetrack or whatever, like it's always where they start. It'll never move, okay? And then your terminal side, that's the thing that changes. It could be anywhere depending on what we want or what we have, okay? Now, you see that I highlighted, this is just an example, so I just put it there and highlighted there. That's my terminal side for this one. Now, another important thing, and I showed you here on the picture, if I were to go counterclockwise, if I follow this arrow starting at my initial point and I go counterclockwise, that is positive degrees. So in math, we have talked about this before, in math, positive angles and positive degrees are actually counterclockwise. I know that seems opposite to you because of everything else in the regular world, but in the math world, counterclockwise, everything is math and it's positive in that way, okay? So that means clockwise is negative. So that's the only really hard part, is to remember which way you're going and what kind of numbers they are. If they're positive numbers, so if they're opening this way, or if they're negative numbers and they're going this way. They start. So just pay attention to where the line comes from. The line comes down to start or comes up to start, even if it goes round and around and around and around, okay? So let's start with the first one. Okay, so number 1 says 215 degrees. So with that, we have to know our degrees or basics, right? Where we start somewhere is always 0 degrees because we haven't moved anywhere, right? Now, if we go straight up, make that nice angle, that's 90 degrees, right? It's a 90-degree angle, so that's 90 degrees. Now, if you completely fall flat again, that's 180 degrees, right? You should know that a straight line is 180 degrees. That should be something you should 100% know from geometry class or in life, okay? After that, another whole 90 around, that's 270. Again, all you're really doing is adding 90 to 180. And then if you added 90 again, another quarter, you get 360. Remember, a whole circle is 360 degrees. So we need to use that knowledge to go, okay, 0 to 90, 90 to 180, and everything in between. 180 to 270 and everything in between. 270 to 360 and everything. And that's if we're only doing the positives. If we went backwards, right, it'd be the same thing. It'd just be backwards. So when we do these problems, and I did 3 of them, 215, so we go, okay, this is positive. So I drew my first line. You see how like thick I made it? Okay. Then I go, okay, 215, well, that's bigger than 90. That's bigger than 180. That's not bigger than 270. So it's somewhere in here. So then you have to use your math. And I showed my math. So I went 215 is 180 plus what? So I figured it out. I subtracted 180. I actually did this. I did 215 minus 180 equals 35. So that's how many degrees I had to go above 180 to get there. So I went, okay. I drew a line. I went around. I went, okay, 90, 180. And then I guessed to the best of my ability because I knew that a quarter of the way through was 45. So then I just subtracted. I got 35. So I was really close to a quarter of the way through, but not all the way. So then I just drew my line. So I show this big line has 215 on it to show that that's my whole degree. This little line has 35 on it to show that that's my distance from 180 to the line. So that's the difference from 180 to my line, which is there. Okay? We'll try a negative one. So negative 40. So negative means, again, I still start my line here. That's never going to change. So negative means I'm going to go down. 40 is less than 90, so I only just go to that and think about it. I'll go, well, 0 minus 40 is just 40. There's no other math to it. So you just go, okay, just go down. Almost 45, because 45 is a quarter of the way. It's almost a quarter of the way, but not. So you just draw a line and you just mark it, negative 40. Again, your drawing doesn't have to be perfect. I know that that's hard for some of you, but you do have to remember that on Alex, you have to do your best, and that's why they'll probably have some kind of spinning something or other. So you'll have to work on that, okay? Now, 480. Now, 480 is a big number, so you think about it. I went, okay, 480, that's bigger than 360. Let's see how much bigger it is. So 480 minus 360 is 120. That means I'm gonna go all the way around the circle, and then I have to go past 120. So what I did was, and this is how everyone does it, we first draw our initial line, initial start, and then you start on the inside. Anytime you make more than one circle around, you always start like a little in because you want to show that you're looping around. You're going to make a spiral every time you make a circle around. So you make one big circle around, and I showed it. So you see how that, I put an arrow there, it showed that I made 360. Then from there, you're going to show how much is left over. Well, 120 is bigger than 90, but it's less than 180. So how much is it bigger than 90? So if you wanted to, you could subtract 90 to see how much is left over. It's only 30 degrees. So then you could figure out, okay, well, this is 30 degrees, right? If you wanted to help yourself out, and then you could draw that. And then you just kind of, again, guess, draw the straight line. You can use a ruler. I did, okay? So it's up to you. It should not look bad. These little lines, if you cannot make them straight, you need to use a ruler, okay? Now, swirls obviously should not be straight, but they should not look like you were having some kind of panic attack at the same time you were drawing these swirls, okay? Oh, there's one more. There's one more definition. In this whole front page, we have one more thing to learn. This is all of day 1 of this. So this is for Wednesday. Just letting you know if you're not reading this. And then the other half of this section, I will keep it on this video so you could pause, work on your stuff, try that homework first. The other half of this video is for Thursday. And then if you want, get ahead, that's fine. And then your quiz on Friday will be on 9.1 and 9.2, and it will be at noon. It will open at noon. You will only get an hour. It'll only be open for an hour. So I would not mess around. Okay, last definition for this part is coterminal angles. So a coterminal angles, co means two or more. It is 2 or more angles in standard position with the same terminal side. So all that means is if we have a starter, which never moves. In a terminal, look at this. There's arrows from all these ways. There's 3 different arrows going to the same line. You know why? That means multiple things can end up in the same location, right? It doesn't matter where we came from. It's like coming to school, right? It doesn't matter how far we drove. Some of us, it takes us 2 seconds to get to school, right? Some of us, it takes us, if we're Luke, right? Luke takes much longer to get to school than most of us, right? It takes me a couple seconds to get to school in comparison to the rest of you, right? So no matter where we are, we all end up in the same place. It's like this. We all start somewhere, and it doesn't matter where we travel, we're going to get at the same place. Okay, so that's what this is doing. So we want to check it, and the only thing it gave us was the 60. So the only information it actually gave us was the 60 degrees. So it did not give us any of these other circles. All it gave us was the 60 degrees. And it says in the instructions, find a positive and negative coterminal. So we need to have one positive answer and one negative answer. Technically, could I have a different answer, then Jason can have a different answer, and Cass can have a different answer, and Tanner can have a different answer? Yes, we could all find different answers. Could some of them be the same? Sure, but we could get different answers depending on what we do. Okay, so it is okay. Just all you have to do is check your math, and we'll see if we get it right. Okay, so they only give us 60. So if you want to take the easy route, the super easy route, based on whatever number they give you, okay, 60, you go. Another positive answer means if we already went positive 60, let's just go a loop around again, okay, and find another 60. And you see that because if you look at this loop, you see how it went to 60 and then went all the way back around to 60. So look over here. Our positive answer, 60 plus 360 is 420. That's what that is, 420 degrees. If you don't put the degrees, you will lose points for it because it is a measurement, okay? It's like writing inches, it's important. And we have the picture drawn, okay? Then that's my positive answer. So there's my positive one. Good. Now, same spot, but that was positive. Now we need to go the negative way. So we go, okay, well, how far does it take for me to get there? So you take the number you started with and just subtract 360. What's the difference? 60 minus 360 is negative 300. How you know you're right is if when you added that number and subtracted a number, did you get one positive, one negative answer? If you did, you're golden. If you didn't get one positive answer, one negative answer, it's probably because this number's too big. And then use a multiple of that number. So if 360 didn't work, what's double 360? 720. So then subtract or add 720, whichever one did not work, or do it twice, whatever. Okay? So here's an example. And I'll do another one with you. Okay? So 130 degrees. So that's our starting point. No picture whatsoever. 130 degrees our starting point. So we need coterminal answers. We need a positive one and a negative one. So let's just do some math. 130 plus 360. If I add those together, do I still get a positive answer of 490? Yes, ma'am, I do. Okay. Awesome, Miss Rinaldi, you're great. Thanks. Okay. Negative. Let's subtract it, see if it works. 130 degrees subtract 360 degrees. If I subtract this and I get a negative number, I am golden. 100% I'm wonderful. Equals negative 230. Done. I have a positive answer. I have a negative answer. I am done. I found my goal. That's all I wanted. Now, if my number is super big, make sure you can see this. Okay. Let's pick 426. That's my starting angle. Okay? That's fine with me. It really does not matter. Now, you have lots of options, and I'm going to show you. Positive options, you still have lots of options. You can still add 426, I already put 62, plus 360. So 426, I can't read that too. Add those together, what do you get? Put the degree sign. Did you get 786? Because I did. Is that a positive answer? Sure. Is that the only positive answer? No. No, because could have added 720. Yeah. You know what else I could have done? I could have taken 426 and subtracted 360. Because that number is bigger than that number, they would still work. Which is the weird part. Because if we would have tried it here, right, when we try our negatives, we would have subtracted it, it wouldn't work. 426 minus 360, right, you try that, and you get, what, 66 degrees? So that's still a positive answer. So there, right there, Just by doing our two things normally, we get two positive answers. So that means we don't have a negative yet. So we did what we normally do, yes, but did it work in this case? No, because our starting initial amount of our degree that they gave us to go with is too big. So when 360 doesn't work, try a bigger number. So now do 426 minus 720, as long as that's the double of that, right? 36 doubled, yep. Right, so then you subtract it. So 426 minus 720. And I get negative 294 degrees. Did you get the same answer? Does that make sense? So if one doesn't work, if you don't get one positive, one negative originally, try doubling, whatever you're subtracting, make another rotation around. So just double that 360. If that doesn't work and the number's still too big, I would go the other way. Or again, just keep making it bigger. It shouldn't happen after more than one rotation unless that number's crazy, but still, okay? So look, I just gave you 3 different answers for one problem. I only need 2 answers, right? So either 2 of those, it just depends on what you do. Now, if you got some crazy numbers, you might want to check. And you can always draw them and go, okay, check my circle, see if that works. They may ask you to draw them, they may not, so you want to look at it. So this is Wednesday. I'm going to flip and do Thursday. But if you want to stop and do that, be good at this before you do the next part, please stop, do that, pause it, come back to this later, okay? I'm flipping. Okay, can you see? Okay, next we're going to talk about radians. So I showed you on my calculator, right, how we can go from radians to degrees. Now, we're going to talk about what radians are. So let's first do the definition. It's right here. I didn't highlight the word, though. It's a long one, okay? So a radian, first part, is used to measure the length of an arc of a circle. That's the first part. Just write that down. Used to measure the length of an arc of a circle. Write that down. I'll take a drink. Next part, 1 radian is the measure of an angle in standard position with a terminal side that intercepts an arc with the same length as the radius of the circle. Period. I'll read it again. 1 radian is the measure of an angle in standard position with a terminal side that intercepts an arc with the same length as the radius of a circle. Okay, so let me make sure you can see this picture. Now, this is not the best thing. It looks better on a board. I can draw circles much better on a board, I promise. Now, again, I still drew my normal grid. 2 up, I think I did 3 this time just so I could get a better circle, and it still looked ugly. Now, before we talked about how we went from 0 degrees to 90 degrees to 180, right? So now I'm going to show you what the radians are. So 0 degrees to 90 degrees is actually pi over 2 in radians. I know radians actually uses pi. I know, symbols, crazy numbers. Now, 180 degrees is a whole radian. So this is 1 radian, which is just pi, okay? So that's important to know. So a half a circle around, so like a half a circle, is a whole radian. That's important, okay? Which means a whole circle is 2 radians, or 2 pi, okay? And I wrote that down to the side. And then 270 degrees, which is 3/4 of the circle, that's 3 pi over 2. Remember 3/4 or 3 halves, right? 3 pi over 2, okay? Now the picture of what they were talking about up here. So A radian uses a radius. So remember, a radius goes from the center, if this was a good circle, to the outside. That's our radius. Well, they also said the arc length is the length from the terminal to the initial. So it's just the length from here to here. And these guys are actually the same. Okay, so the arc length and that guy's the same. And then theta here represents an angle, which he always has before, and he's always on the inside of there. We're always trying to find the inside of that. Now later in harder classes, moving on, we may not make it in this class, but you will make it in the next class. You may have to find pieces and parts around, okay? Now, important part, start it, and oh man, I ripped through the paper. Okay, I don't know. Oh, there was something under there. Okay, important. We have to be able to convert degrees to radians or radians to degrees, okay? Because right now we don't have all that stuff memorized in our head. Later, you're gonna have to, and I'm saying this with the utmost importance, it is so important sometimes. It's like your math facts. How much easier is it to know that, like, 5 times 7 is 35 in your head than to have to take the time to go, okay, 5 times 7, oh, that's 35. Like, how much time do you waste on your calculator by knowing that? Same thing goes with this. Knowing your radians on a circle, and there is a whole unit circle that has every degree, and with every degree, each degree has a radian that matches up with it. Like, you just learned 5 of them. You got 0, pi, pi over 2, pi, 3 pi over 2, and 2 pi. You just learned 5 of them, but there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 17 of them, okay? So, like, knowing that saves you so much time. Now, there are some you'll never know, which is what this is for, but like most of the time, right now, all we're doing, this stuff you should know, and you want to learn, because when you know them in your head, it saves so much time. I don't have to take the time to learn them because I have memorized and made connections between my degrees and my radians, okay? For now, we're learning this. Later, you should not need this, okay? I'm just giving this little hint because that's why you're expected to be able to do a 30-question quiz in 45 minutes, because some things should be memorized. Because if you have to do the long way, you'll never finish. That's the whole point. You should know things. It's like basic math. That's why they used to give you multiplication, like times table quizzes. You had a minute to do them. I mean, at least I used to, and it was like in the 3rd grade. Okay, so anyway, my rant's over. Degrees to radians. So if you have a degree, I just put X degrees. Okay, a degrees, you take your degrees and you multiply it by pi divided by 180. You always, whatever you want is always on top. So radians, pi radians over 180. Because, here's your example. We have negative 30 degrees. We want to turn it into radians. So you take negative 30 times pi over 180. The degree signs, like these both have degree signs on, right? Since one's on the top and one's on the bottom, they basically cancel out. You turn this into one fraction, 30 pi over 180. Well, simplify, negative 30 over 180, that's negative 1/6. That pi, he just stays there. You write the word radians. So all you have to do, oh, you couldn't see all that, I'm sorry. All you have to do is go, okay, take the two numbers, make them one fraction, simplify. That's all you're doing. Cancel out what's common. So degree signs cancel out, it's a radian now. Or the pi's cancel out, and now it's a degree. Hence this one. Radians to degrees. So a number pi, it would be some kind of pi, whether it's pi over 2 or 2 pi or whatever it is. Whatever you're looking for, it's on top. So this is 180 degrees over pi radians. Okay? See how they're both pi radians? So the pi and the radians will cancel out. And whatever this is, we'll just multiply by 180. So here's your example. 5 pi over 2 times 180 over pi. I never write the radians until the final answer. So look, the pi's cancel out. So all you're left with is 5 over 2 times 180. You could either type that into a calculator or use your head and do 180 divided by 2 and then times 5. It's 450, and then since all you're left with is the degree sign from 180, it's degrees. Okay, there are a few questions like that in your homework. In the second day's worth of homework, there are stuff from the first day. So make sure you pay attention to that. And then there is stuff like this. And then the last section, there's only 2 of these, and it's kind of in the middle of your homework. The rest is everything we've mixed together. I'll make sure you can see it. Okay. Next is arc length, which is basically what we did up here. We talked about a little bit. We're gonna like actually dive into it now. So arc length. So arc length is for a circle with a radius. So here's our circle over here. Remember, our radius is from the center to the outside. Now theta is still the angle on the inside. And the central angle, it has to be in radians. Our central angle is theta. Now, the big takeaway from that is if it's not in radians, you use one of your formulas. Well, your only formula, degrees to radians, you have to turn it into radians. If it is not in radians, you have to put it in there. So there's a little math. Also, if it's not in the correct measurement, if it says it wants it in feet, but it's in inches, you have to do that conversion at the end. If it says it wants it in hours and you have it in minutes, obviously you have to do the conversion again at the end. It's just like any other, and again, word problem. I know how much you hate word problems, but these are set up that way. Just every time you read something, and I read this one and wrote down it, and I'll read it to you again. Every time you read a word problem, I'll even show it to you. You have to look at it and go, okay, what's the important information? And when you write down numbers, important information, you should also write down the words that go with it. So if it says 33, because I made this mistake the first time, because I always do it sometimes, like when you're trying to rush, you don't write down what 33 what? 33 penguins? 33 lagoons? We don't know what 33 means, right? So we want to look at it. So I'm going to open. So we're going to do that. And then S represents your arc length. I'm flipping to that problem right now so you can see the actual word problem. And then, so the arc length is equal to the product of R and Q. So the actual equation is S equals R times theta. It's literally that simple. Okay, let me pull out. Okay. Okay. Move my calculator. Now, first problem. Look what I wrote down. Listen to the problem. Monster truck tires have a radius of 33 inches. So I wrote R equals 33 inches. Inch is important. How far does a monster truck travel in feet? So I wrote answer in feet because I went, oh, that's crazy because that number, that measurement is different than that measurement. So that's super important. Just after 3/4 of a tire rotation. So it only rotated, only moved 3/4 of the way. So remember, if you have a tire, if it started here, it only rotated 3/4, which is a lot if it's 3/4 of the tire. 3/4 of this. We don't know how much that is, but 3/4 of that. Okay, so think of a tire as a whole circle. 3/4 of that was moved, okay? So we don't know what theta is. Theta represents this angle. So what is 3/4 of this? So you have to think about radians. 1 radian, or pi, is only half of it. Isn't that bigger than that? So we can't find 3/4 of that because our answer is already more than that. So what's 3/4 of the whole thing? What is in radians, this whole thing? It is 2 pi. So what we do is we take 3/4 times 2 pi, because 2 pi represents a whole circle. So 3/4 of times 2 pi. So we do 3/4 times 2, and then put the pi on the end. So 3/4 times 2 is 3/2 pi. So that is my theta. That's my radius. R and theta, look, R and theta equals S. We just can multiply them now. So S equals 3 pi over 2 times 33. So I have 3 pi over 2 equals 33. That is 155.5. I don't think it ends. Let me work. 3 pi by 2 times, let me put it in parentheses, times 33. Let's see if it, okay, so it was 155.508. Since there's a 0 there and that couldn't round, it's okay to leave it there. And then this was in inches. What did we want our answer to be in? Feet. Well, inches is smaller than feet, which is great. So that means we go inches. How many inches are in a foot? 12. So I had to divide that number by 12. So divide by 12, I just typed it into my calculator, enter. I got 12.959. That 5 right there rounds that up to be 13 point, it's about approximately 13.0 feet. If it asks for 1 decimal place, you should always put everything in 1 decimal place, just put the 0. I would just do it. If it marks it wrong on Alex or anything like that, I look at them and go, oh, that's the same answer. They marked it wrong because you added a 0, it didn't have a 0, then I will still give you the credit for it. It did it on your last quiz too. I give you the credit for it because that's silly to me. So don't even worry about that. Put the decimal place. Okay? Let's try another one. This one, I'll let you look at the problem. Okay. Okay. Number 5, it's in the bottom. A circle has a diameter of 9 centimeters. Find the arc length if the central angle is 60 degrees. Round to the nearest tenth. So it tells you where to round, right? 1 decimal place. So when I did that, I wrote, oh, got a little fuzzy. This is what I wrote down. My diameter is 9 centimeters. My radius, so that means I did some math. 9 centimeters is my diameter. Your radius is half your diameter, isn't it? So I divided by 2, 4.5 centimeters. Okay, because I don't really need that now, right? Okay, over here, theta is 60 degrees. Well, last time I checked, it told me up here, my theta had to be in radians. So I need to turn 60 degrees into radians. So I'm going to multiply it by pi over 180. So 60 over 180, put the pi on top, it's pi over 3. So theta is now pi over 3. Now I can take, so then I have this guy and this guy. All we do is multiply them. You just type them straight into the calculator, right? So I just type in 4.5 times, parentheses, pi over, what is it, 3. And I get 4.71. It said tenth. So I wrote S equals 4.7. My radius was in centimeters, so I write centimeters. And it is, that's it, done. Okay? So you just have to pay attention to what it asks. Make sure your measurements are what it's asking you, okay? Just pay attention to the question. Make sure you have everything converted correctly. You only have 1 measurement in it. Just make sure you have what you need. Okay? And you know how we were talking about the unit circle with the degrees and the radians before? I want to show it to you. It is right there. It's that big guy right there. He's pretty intense. Let me see if I can focus my phone. There we go. There he is. See? That's him. You see how all the degrees are on the inside? All the radians are on the outside? You see in pencil how I kind of blocked off the first quadrant? That's because if you can memorize the first quadrant, everything kind of adds up as long as you can add fractions together. So that's a whole other ballgame. But this guy, he's so important. Yeah, the only reason I make it through anything and I can do anything in this section is because I have this memorized and I can do basic addition. Okay, so if you can do those 2 things, you will be okay. You just have to put the extra effort in, okay? Because I love doing minute unit circle quizzes. Fill it in, all the blanks in a minute. Trust me. Just letting you know, okay? So that is the 2 days worth of quizzes. Your quiz will be on Alex. It will be up at noon. You will get exactly 1 hour to do it. It'll only be open for 1 hour. That is all the time you get. Do not be hasty with your time. I will not give you extra time. I will not open another time. So you better be prepared any other time. This is the time you should be in school, so there should be no excuses. There should be no practices. All practices are after at least till 2, so you have plenty of time to do a quiz from noon to 1. And you better be awake for it. Good luck.